lesson time. Yeah, lesson time. Eureka Math, grade 4, module 6, lesson 1. Let's do it, y'all. Here we go. All right, what are we doing here? We're going to use metric measurement. So metric, so we're talking about, what's that? Metric, like centimeters, meters, liters. Okay, remember that? Grams, kilograms. Okay, the metric measurement. To model the decomposition. Remember, decomposition means what? All right, breaking it down, right? When you take numbers and break them down in different ways of one whole into tenths. So here we are, embarking on the world of decimals, and I think you're going to find this pretty straightforward. Let's dig in. Okay, so there is a sprint. So if you are going to do the sprint, go ahead and pause and do it. There's a side A and a side B. Mark your number correct and how much you improved when you get to side B. But as for I, we're going to plunge ahead. Let's do it. All right, so now, when I say the whole, look right here. Yeah, see, so what is the whole bar, the whole tape measure here? It's 20. Its value is 20, the whole thing. And I've divided it into 10 parts here. So the whole is 20 divided into, right, 10 parts. So now, how would I express that as division? Okay, well, let's look at this first one together. So don't worry about answering. Okay, so I'm taking 20, dividing it into 10 parts, and there's 2 in each part. So 20 divided by 10 equals 2. Okay, good. Now we understand how this works. So now if I say, all right, let's jump right to what's the division sense? Well, the whole is 200. Again, divided into 10 parts. That's what we'll be doing. You see up top it says divide by 10. So 200 divided by 10 is, yes, you see each part is 20. Okay, so think about it. 200 divided into 10 parts, each part is 20. So if I had $200, woohoo, $200, oh, and I wanted to share it with 10 people because I'm feeling generous, I'd give them each a $20 bill, right? 20, 40, 60, 80, 100. 20, 40, 60, 80, 200. Okay, I'd handed out those 10 $20 bills, $200 in all. You see I can work it backwards there as multiplication. Did you catch that? All right, so 200 we see here is the whole divided by 10 is 20. All right, so now we get the idea. So now if we see this, at first you said, whoa, this is different. But it's not. It is the same. Yeah, it's 240 divided by 10. Every time here we're dividing by 10. 240 divided by 10 is 24. Okay, is that making sense? Good. 240 divided by 10 is 24. Okay, so now 400 divided by 10. Yes, we could see it's 40. Does this bring to mind something that we did oh so long ago, way back in yonder age gone by in module 1? That's right, we were doing this. We were riding the times 10 slide and back down the divided by 10 slide. That's exactly, absolutely what we are doing right here. We're taking 400 divided by 10 is 40. Can you picture that place value chart in your mind? Ones, tens, hundreds, 4 dots in the hundreds place. Divided by 10, they go down to the tens place. It's beautiful. The circle is complete. All right, so now 430 divided by 10, 43. Okay, you're getting faster at this. All right, hey. I'm trying to show off. All right, 850 divided by 10, 85. Okay, good. We see how it works. 8,500 divided by 10, 850. Right, the answer's staring me in the face, Mr. McGrath. Yes, it is. All right, so 8,500. Picture that times 10 slide, that divided by 10, going down the place value chart there, 850. We can do it with this number as well, can't we? 8,570, again, divided into 10 parts, 857. All right, 6,280 divided by 10, 628. You see how this works? It's beautiful. I love it. Okay, so let's go on then. Now that that's easy, let's do something else. I can compose, yes you can, and decompose 1 kilogram representing tenths in fraction form and decimal form. Let's try that, okay? All right, so we're going to put tenths in fraction form and decimal form. And this is what makes decimal so straightforward, is that you work so hard through it, like 41 lessons on fractions, and now you get the big payoff. Here we go. All right, so here's a scale. Isn't it cute? I think so. And we're going to put cute little bags of rice on our cute little scale. There's one, and it weighs, now you might be tempted to say 1 kilogram, but you see there's that 0, and then the decimal point, and then the 1. So it weighs 1/10 kilogram. And that is the mathematically correct way of saying that. You say 1/10 kilogram. Sometimes I and you and your mama too might say 1/10 of a kilogram, and that's not necessarily wrong, but the mathematically proper way is 1/10 kilogram. All right. Hey, got more rice? Got rice? Got rice? Here we go. 2/10 kilogram. Count with me. 3/10 kilogram. 4/10 kilogram. 5/10 kilogram, 6/10 kilogram, 7/10 kilogram. The excitement is mounting, isn't it? 8/10 kilogram, 9/10 kilogram. Uh-oh, now what? Evil laugh. All right. Yeah, you would be correct to say 10/10, wouldn't you? 10/10 kilogram, but that's, one whole. Picture the fraction in your mind, 10/10. Is 10 over 10, isn't that equal to 1? 1 kilogram. We could say 10/10 kilogram, that would be correct, and also 1 kilogram. All right, so how much do all 10 bags of rice weigh? 1 kilogram would be a good answer. So if we make a tape diagram now, okay, so we're going to show the 10 equal parts that make up this kilogram, right? So there's a nice, look at that tape. It's beautiful. The whole thing is what? 1 kilogram divided into 10 parts. Aha, is this reminiscent of what we started off doing? Yes, it is. So each one is 1/10. See? So here we go. There's a bag of rice. What's the fractional part of the whole kilogram, that one bag of rice? It's 1/10. Oh my goodness, you just made the connection. We say the same thing in decimal form as we do in fraction form. I'm frothing at the mouth. I'm so excited. 1/10 kilogram. 1/10. We say fraction, 1/10. You see the fraction? 1/10. You see the decimal, 1/10. Woo! It's the same thing. We say the same thing. Glory, glory, hallelujah. Okay, you see how we write it as a fraction now? We write it as 1 over 10, 1 fraction bar, 10. Numerator, denominator, remember all that? Okay, 1/10. And then there as a decimal, 1/10, we also say, but it's 0.1. And so I'll make this distinction right here. Sometimes I'll say, how do we write this decimal? And we'd say 0.1 because I'm describing how to write it. But when we read this as a math number, we'd say 1/10. We just kind of like leave the 0 out of it. We just say 1/10. There's a 1 in the tenths place. Okay, so there's a distinction there. How do we write it? How do we read it? All right, so now, what's going on here? Yeah, 2/10 kilogram. Fraction form, decimal form, same value. Oh, chills. Let's keep going. 3/10, 4/10 kilogram, 5/10, 6/10, 7/10, 8/10, 9/10, and again, yes, 10/10, or I could say 1 kilogram. Boy, the world's a beautiful place right now, isn't it? All right, so 1/10, see I wrote it in word form there. It equals fraction form 1/10, decimal form 1/10. Those are equivalencies. 1/10 equals 1/10 equals 1/10 is how you'd read that. All right. Holy number lines, Batman. What are we going to do here? Well, look, we have going from 0/10 up to 10/10 in fraction form. Oh, and there they are in decimal form, okay? Those are all equivalents. See, what? Pick one out. 8/10 is 8/10, right? All right, so now look. What be this here? Now, you might be tempted to say a yardstick, and you'd be very close, but it is a meter stick, okay? Because remember, we're doing the metric thing. So 2/10, so now we're going from grams and kilograms, a measure of weight, to a length measurement. We're going to deal with meters. And we might even have a guest visit, a cameo appearance from centimeters. All right, so 2/10 meter plus 1/10 meter equals what? Well, where did we end up on our happy little hopping number line? That's right, 3/10 meter. Easy so far. Guess what you just did? You just learned how to read decimals, find decimal fractional equivalents, and even how to add decimals. You are a superstar. Gah! Love it. All right, 4/10 meter plus 3/10 meter is, dang, you good at this, 7/10 meter. All right. 2/10 meter, oh, I'm going to throw you a curveball. You know it just when you start to get good. 2/10 meter plus 8/10 meter. Okay, we could say either 10/10 meter or 1 meter. And notice I write it as 1.0, but I would read that in decimal form as 1 meter. Or you could say 10/10. That would be technically correct. Oh my goodness, now we're going to do subtraction. Amazing. 7/10 meter minus 6/10 meter leaves, there it is, your answer staring in your face, 1/10 meter. Beautiful. How about starting from 5/10 meter minus 3/10 meter? 2/10 meter. You could see it. It's right there. Beautiful. All right, so now here's the problem set. And I'm not going to do this whole thing with you. What I'll do with the problem set and the exit ticket is just kind of like flow right through it with you, just to kind of show it to you. And if you're going to go do it yourself, then great, go do that. And then, of course, there are the homework time videos when we get to that. So don't forget first to write your name and your date up here, like that. Okay. So what you're doing here is what we did before with the tape diagram. And your instructions here are the first 7 units. So you're going to 1, 2, 3, 4, 5, 6, 7 units. Label the whole number line, and then label both in decimal form on top and in fractional form on bottom, and then circle the one that represents the shaded part. Well, they already told you it's the first 7 units. Okay, all right. And now this is kind of neat, although the last one begs a little explanation. Okay, so this 1 liter bottle is filled halfway up, right? 5/10 liter. And notice, by the way, I'll point this out many times, that the liter abbreviation is a capital L so as to discern it from the number 1. So 5/10 liter, say it with me, 5/10 liter. How would I write that as a fraction? 5 up here in the numerator, 10 down here. I often have students write 5/10 in this one box, but the 5 goes here, the 10 goes here. I know I'm giving you answers, but I'm showing you how to do this because it can be confusing otherwise. And then here, oh no, I'm sorry, take that back. Totally wrong. Suck the words back in my mouth. I jumped the gun. Look, you actually have to pay attention sometimes. Look at that. Even the teacher must learn. 1, 2, 3, 4, 5, 6. See, so if you wrote down that answer, you was wrong right along with me. It is 6/10 that it's filled to. My apologies. So it would be 6/10 liter, which we then write as 6/10 liter in decimal form as well. And this one we're going to be a little more careful. Yes, we could go backwards and say 9, 8, but we can count up as well. 1, 2, 3, 4, 5, 6, 7, 8/10 liter, 8/10 liter. Now this one, you're doing backwards. You might be tempted to say, oh, there's 0/10 liter there, right? But what they want you to do is, per instruction, shade the last bottle to show the correct amount. So here's the correct amount. It's over here at the end. 9/10 liter, right, as a fraction, 9/10 liter, and then shade up to 9/10 of a liter. Okay, so that's what you're doing there. Here you're just writing in fraction or decimal form. So here they tell you in decimal form, right, and you'd write the fraction. Here they tell you fraction form, you'd write the decimal. And here they're a little tricky about it. They have a, instead of a digital scale, a mechanical scale, I guess you call it. Look that up. Post in the comments if you know what that's called. So, so there's 5/10 kilogram there. So 4, 3, 2, or we can count up from 0, 0, 1/10, 2/10. So this is at 2/10 kilogram. Okay, and I'm going to ask you to write it in both fraction and decimal form for this last one, because here they give it to one and you write it the other. So in this one, write it in both. Oh, stop whining. You'd be done with it already. All right. Notice Ladybug's buttocks are aligned with the 0. That's important, okay? So you know you are measuring correctly. And you look at her head there, and it's aligned with this line. So each of these lines is 1/10 of a centimeter. This one here is 1 centimeter. So for example, this first line would be 1/10 centimeter. The next line would be 2/10 centimeter. So they wanted to say, how big is the bug? What's her length? How long is she in fraction form and decimal form, which you can see right there. She comes to that long mark in case your copy you're looking at isn't too clear. Now, how far does she need to walk before her nose? See, I said buttocks, and they're saying she has a nose. I don't know. Do ladybugs have noses? Do they have buttocks? I leave it to you to research. Post it in the comments. Before its nose is at the 1 centimeter mark. Well, it's currently here, right? And so how many more? So you're basically counting like on a number line. And note that this should be a fraction or a decimal. I would use a decimal because generally when you are talking about centimeters and meters, metric system, you use decimals, not fractions. So this should not be like 6 or 5 or 3 centimeters. It should be something like 3/10, 5/10, 6/10, 9/10. That it should be in decimal form. Okay, now here you're doing the adding and subtracting, and notice that A goes across. And these are the same examples. In fact, if I read this, I'd read them the same way. 8/10 centimeters plus what is 1 centimeter? 8/10 centimeters plus what is 1 centimeter? You read them the exact same way in fraction and decimal form. And so you have to fill in the missing part there. I won't belabor that. And here you're just doing matching. And I'm not sure if this is a tricky one. Sometimes they have tricky ones where things match in a multiple way. No, this one's very straightforward. Okay, so it's 3/10 in unit form. You have 3/10, and then they did this one for you. 3/10 in fraction, 3/10 as a decimal. Just finish the rest of it there. Oops, went too far. Okay, and now here's the exit ticket. So you're going to fill in the blank. This is the same as what we just did up above. So I won't go into that. And then again, there's another little matching chart with turns the same numbers, and you do the same thing there. Then you get to the homework, and for the homework, you should go to homework time, but you notice just flipping through the homework quickly, it's actually identical to the problem set. So there we go. You did it. Happy you, happy me, happy world. You'd gone and done it again. You completed another Eureka math lesson. Go on, take a break, get a glass of water, go outside, get some sunshine.